Hello and good day. We are from Group 49, and for our Engineers in Society project, we will be discussing about the Raub Bridge collapse incident. Our group comprises of me, Eng Zijin, Jishnu, and also Muhammad Nazan. This is the table of contents for our presentation. It includes the introduction, discussion on topic, technical engineering issues, ethical reasons for failures, recommendations to prevent future problems, and last but not least, the conclusion.
I'll be introducing our topic of Raub Bridge collapse. So, first of all, flood events in Malaysia have increased due to intense rainfall and changing environmental conditions. Bridges are vulnerable due to floods because strong water flow can damage foundations and structural supports. In January 2021, severe flooding in Raub, Pahang, caused a partial collapse of the Raub Bridge, disrupting the transportation in the area. The incident highlights the importance of resilient bridge design and proper infrastructure maintenance. Now let's discuss this a bit more. Bridge scours occurs when fast-moving water removes sediments around bridges' foundations, weakening structural stability. Flood debris such as logs and vegetation can increase pressure on bridge piers and accelerate damage. Many bridges were designed using historical flood data that may not reflect current climate conditions. Engineers must ensure proper design, inspection, and maintenance to improve infrastructure safety and reliability.
Today, I will be highlighting the key causes behind the Raub Bridge collapse, focusing on technical and ethical failures. First, from a technical perspective, the design was deficient. Engineers failed to account for rainfall, flooding, and soil erosion, and in some cases, unqualified personnel were responsible for critical bridge design tasks. During construction, poor workmanship and substandard materials were used, with clear violation of safety codes. Maintenance was also neglected, inspections were irregular, and repairs were delayed despite visible defect. Finally, risk management was overlooked with no flood resilient measures or contingency planning for extreme weather. Together, this issue created unsafe, non-resilient structures vulnerable to disaster. Next, the collapse also reflects ethical shortcomings. Public safety was compromised when cheaper materials and rush deadlines were prioritized over lives. Professional integrity was undermined by rubber stamping designs without proper review, while transparency was lacking as engineers failed to disclose structural vulnerabilities. Competence was also another issue. Critical tasks were assigned to unqualified personnel, breaching both legal and professional codes. In short, the route bridge collapse was not just a technical failure, but an ethical one. It reminds us that engineering is not only about calculations and structures, it is about responsibility, integrity, and safeguarding public trust.
My name is Eng Zijin, and I'll be talking about the recommendations to prevent future problems. So, these recommendations focus on upgrading technical standards, strengthening regulatory enforcement, and integrating sustainability into engineering processes. Key measures include updating flood design limits, real time monitoring systems, stricter penalties for negligence, and mandatory ethics declarations. Environmental actions like riverbank bioengineering and SDG aligned KPIs ensure long term resilience. We have come to the end of our presentation, and to conclude everything, the Rao Bridge collapse teaches us that engineering failures happen when technical shortcomings combine with ethical lapses. As engineers, we must adapt to changing climate conditions, uphold the Engineers Act, and also integrate SDGs into our work. Ultimately, our responsibility is to create infrastructure that protects communities and also remains resilient for future generations. That is it for our presentation. Thank you very much.